Welcome to my sixth video recording and the fifth class on kinematics. And today's topic is vector resolution, and we'll solve a few problems. Now, for those of you who have not gone through my previous lessons, I advise you to please go through, so it will be easy for you to grasp from here onwards. So let's dive straight in. Now, let's begin with a small story here. Let's assume that this is a river and you and your friends live in a village and you guys own a boat. So let's assume this is your boat, right? And you have decided on one Sunday that you want to take your boat and spend some time here, and there's some you want to do a picnic here. You want to come to the other side of the bank for a picnic, right? So it's all nice places to see here. Okay, and now, and you know that this is a river. This is the upstream, and this is the downstream. So basically what upstream means and what downstream, upstream, that means your river, this basically means that the flow of direction of the water is in this direction. So that's why this is upstream and this is downstream, right? Now, let us say you all know that the velocity of the river, we'll call it as VR, it's a vector quantity. You know that it is 3 kilometers per hour. Let's say it's been this way for ages, so you know it from your friends and whoever lives in your village. And you also know that your boat, the velocity of your boat, we'll call it as VB, is 5 kilometers per hour. 5 kilometers per hour, okay? You also know this, right? So, and you have to, and this is your starting point A, and you have to get to this point, which is your landing point for your picnic. So it's basically a straight line. So it's basically a straight line like this. Now my question to you is, can you just steer your boat straight from A to B in the same direction? Please take a note. Please take a note of the head of this boat. This is the direction. So it's pointing exactly towards B. Okay. I want you to keep an eye on this, the head of the boat. That's the direction. So what will happen if you steer the boat straight away in this direction? Tell me. Now, since the flow is in this direction, since your river is flowing in this direction, what will happen is it is going to push your boat. It's going to push your boat in this direction. And you might ultimately end up in somewhere at C. You might end up at C, right? That is because you have a constant push of the river from the northern side, from the upstream to the downstream, right? This is very logical. You can understand this without getting into too many details. So the question now is, how will you get to B? How will you get to B? So the answer lies in the fact that you will have to steer the boat in a direction which is in this direction. You will steer the boat somewhere in this direction. So if you steer the boat in this direction, what will happen is you will ultimately end up in B. So let us now draw up the vectors, right? Let's understand the vectors. So what's the velocity? What's the velocity of the river? River is 3 kilometers per hour, and it's in which direction? So let me draw it here. Let's say V river. Okay. It's in which direction? It's downwards. Okay, so if I draw this segment, it is straight away downwards, right? This is the direction of your VR. And what will be your VB? Your boat should be steered in some direction. We don't know what that direction is, but it is going to be somewhere in this direction, right? And since you want to get to B, which is your resultant. Resultant basically means result. So the result of the direction you take should be straight. So the resultant should be between A and B. So your resultant will be your VR, I'll say. Resultant should be definitely a straight line from your A to B. So we have now we have two vectors. The vector of the velocity of the river represented by VR, the velocity of the boat represented by VB, and the result we want. The result we want is to travel in a straight line from A to B along the x-axis. Now, can we take these three and draw our vector? Let's try and do this now. So you can start. So basically, what are our base vector? This is one vector, this is our second vector, and this is our resultant vector. So let's now go ahead and draw it. So you can start either with 1 or 2, it doesn't make a difference. Ultimately, it will be the same thing. So let's begin with 1. I'll demonstrate both to you. If I start with 1, my first vector will be like this, my second vector will be like this. And if I begin with 2, my first vector would be like this, and my second vector would be like this. In either case, my resultant will be starting from here to here or from here to here. Why? Because this is the starting point, this is the ending point. In this case, this is the starting point and this is the ending point. So you see, the resultant in both the cases is just the same. The magnitude is just the same. So now how do we now since we know the values, so let us substitute the values. Now what is this? This is velocity of the river, and this is the velocity of the boat. In this case, this is the velocity of the river and this is the velocity of the boat, right? So in either case, you see, in whichever way you solve it, you are going to get. So what is the velocity? What have we taken as a velocity of the river? It is 3, and for boat it is 5, right? So if this is 3 and this is 5, in this case, if this is 3 and this is 5, then our resultant will be equal to 4, or 4 here. So why this is so? By Pythagoras theorem, right? So because this is a right angle triangle here, right? Okay. So now, therefore, what we get? Our VR resultant is nothing but, right? It is 4. Is 4 kilometers per hour, right? So this is our effective velocity. Now the question is, at which direction should I steer the boat so that I get from A to B. So we already know that we have to steer it in this direction, but the point is, what will be this theta, right? So for that, all we need to do is calculate this theta, or if I can extend this like this, calculate this theta, right? It is one and the same, right? So what is theta now? How do you calculate theta? So by trigonometry, we know that tan theta is equal to 3 by 4, okay? Or if I take this also, it's the same, right? If I extend this and extend this here, this will be 3, right? So tan theta is equal to 3 by 4, or theta will be equal to tan inverse 3 by 4, right? You can do the calculation and you will get some value for theta. I'm not doing this thing. This will be the answer. So this is the basic idea of the application of vectors. Basically, I'll give you another very interesting example. Let's look at this. Let us assume that this is the runway. and there is a plane which is coming to land, right? Now what will happen? Apparently it looks like this plane is going to come and land straight away. There is no problem, right? Now what happens? This is the first case scenario. Now let's look at the second case scenario. Again the runway. And now what is happening is, let us assume that there is a wind blowing from this side. There's wind blowing. And now the plane is again positioned like this, like before. Now what will happen? What will happen? Can you tell me? This wind is going to blow the plane away. After some time the plane will be in this position. After some time it will be in this position, right? After some time it will be in this position, and it will actually miss the runway, right? You can see the plane is missing the runway. So what will happen is, so what should the pilot do? The pilot, what he will do is, he will have to point the nose of the plane in this direction, right? He'll have to point the nose in this direction so that the plane cannot be pushed and just before touchdown the pilot straightens the plane. Now so if I can plot this with the vector, you can see this is the vector for this. What is this vector? This vector is the vector of this is the velocity of the plane. What is this vector? These vectors. So I'll take one of them. What is this? This is the velocity of the wind. So you have 1, you have 2. And how you want the plane to move? You want the resultant to be in a straight line. Right? So this is your resultant. Therefore, now let's draw it as simple as it is. So first vector is velocity. This is your velocity of wind. Second is velocity of the plane. Let's call it. And this is your resultant, which is along your runway. So the plane comes and lands straight away on the runway. So you get the idea, right? And this is again 90 degrees, and you can use your Pythagoras theorem, and if you have to find out the angle of the plane that the plane is making, this will be theta, right? That's all. So what I suggest is, please go to the internet and check a few videos on crosswind landing of aeroplanes. They're very interesting. You can see how the planes totally are oriented in a different direction, yet they are going straight and landing on the plane, landing on the runway. So I'll see you in the next class. Thank you.